shell sort, devised by Donald L. Shell in 1959, is a modified form of the insertion sort algorithm. It starts by sorting widely spaced elements and then gradually reduces the gap between them. This systematic approach boosts sorting efficiency, making shell sort particularly useful for handling large datasets.
Time complexity. The time complexity of shell sort varies depending on the gap sequence used. In the worst case, it can be big O of n squared, but with the good gap sequences, it can perform close to big O of n log n. Space complexity. Shell sort is an in-place sorting algorithm, so it has a space complexity of big O of 1. Stability. Shell sort is not a stable sorting algorithm, meaning it may change the relative order of equal elements. Overall, shell sort is a faster sorting algorithm than insertion sort, but not as efficient as some other algorithms like quicksort or merge sort in most cases. Its performance depends on the choice of gap sequence. To explain how shell sort works, let us use a given example. Consider an integer array with elements 73, 56, 10, 41, 37, and 32. The first step in this sorting algorithm is to determine the value of n, which denotes the size of the array. In this example, n is equal to 6, as there are 6 elements inside the array. After finding n, we proceed to calculate the gap size for our first pass, which is simply n over 2. In this case, our initial gap size is 3, since 6 divided by 2 equals 3. Elements with a gap of 3 are then compared and swapped if they are not in order. In the first loop, the element at index 3 is stored in a temporary variable and compared to the element at index 0. If the element at index 0 is greater than the element at index 3, the positions of the elements are swapped. In this case, 73 is greater than 41, so the elements are swapped. Since there are no more elements at the left of 41 with a gap of 3, we proceed to the next loop, comparing the elements at index 4 and index 1. Just like before, the elements are compared and swapped if they are not in order. This same process continues for all the remaining elements. After the first pass, the current gap size is divided again by 2, and the resulting quotient becomes the value of the gap size for the next pass. Hence, our gap for the second pass is 1, as 3 divided by 2 without considering the decimal equals 1. When the gap size is reduced to 1, we perform a regular insertion sort for the last pass. To further understand how shell sort works, let's take a look at another example.